You're supposed to send me an email.
I didn't have an email.
Oh, you don't have my email address?
So I'm just telling you the differences.
I'm pretty sure he was saying that people
It's also on the website. All right, no more on today. Let me welcome the freshmen back. Good to see you guys. Good to see everybody. Did the freshmen get my email? Or other people who were gone Monday? You heard that I recorded my lecture. You watched it if you like, and you maybe some of you even stopped by and picked up the free things that were handed out on Monday as well. That would be great. If you haven't yet done that, and you weren't here on Monday, go ahead and to the blue bin in the back and pick up the free things that you're missing, including the assignment sheet and some notes on homework 1, and then the actual homework 1 sheet. Homework 1 is sizable. It's going to be assigned over the course of 2 days. I don't know if some people count that as well, but so it'll be due tomorrow, and the quiz on Friday. We actually are going to have a quiz on Friday this soon, right? It is only on homework 1. It's like the let's get the boring stuff out of the way quiz, right? Kind of deal. I don't know. We shouldn't phrase it that way. I mean, this stuff could be exciting, right? Let's try to make it exciting. Could be. I mean, we got into the box plots on Monday, didn't we? Riveting. That website that I pointed you to. Oh yeah. For example. So, in an attempt to expedite any boring things, I am giving you a copy of this PowerPoint today, right now. Okay. It'll also be on Headline, of course, but I just don't want you to take notes on lots of boring things that. Okay, it's a little small, but your eyes are good, right? I know. Don't say I never gave you. One grade. I mean, you were. I tried at some point to put my PowerPoints online early, but sometimes I don't make them till last minute. Okay, so so I should say again, I'm giving you the notes here. I want to go kind of through these ideas quickly because I don't think that IB cares about this stuff as much, but I'll refer you to IB Stat for those who haven't yet taken it. All of you should, maybe make time in your schedule in the coming years to take IB Stat. You can take it while you take another math class, as you can see. The people in here are doing that. Or higher level math also gets you exposure to some of the ideas in more depth in statistics. So, okay, so please, stay awake at least. All right, you ready? Set a low bar to set. So we want to talk about, this is right in front of you too, so like I said, I'm going to go kind of quickly through these. We can talk about data being classified in 2 ways. Numerical or categorical, and actually maybe the way we prefer is quantitative versus qualitative. Words I think that you already have heard before. I'm putting up also these examples, and all of these examples I think are fairly prototypical, right? Numerical is stuff that is numbers, right? And qualitative is stuff that isn't numbers, yeah? So I think these are fairly prototypical examples. Would you agree? Do you have any questions about the examples we have up there? Do you have any questions about what we mean by numerical versus categorical? Why are you recording? Because I think this is going to be really valuable. In case you want to see this amazing presentation. Are you ready to record it? I'm going to start doing it again. All right, so what about this one where my staff people can help me out too? Do you have any ready examples of things that appear numerical, but in fact are qualitative, or rather appear, we should use the right terms here. Quantitative versus qualitative, something that appears, my staff people are all over this. Go ahead, Fonda. Zip codes, all right, is that what you're going to say? Nice. She stole yours. You have another one, though.
Like student ID numbers.
Student ID numbers, is that what you're going to say? All right, yeah. Okay, and can you explain why, for all of these license plates, for example, why even though that seems numerical. Seems numerical to me. Well, that one actually doesn't seem numerical to me because it might have letters. So okay, so let's talk about zip codes though. Those are numerical. Those are for sure numerical. No letters or colors involved.
It's so good for not necessarily like use your sign for like for almost.
It's like they don't have a
They're not
relationship with increase. Like I don't know how to. It's like some sort of. Yeah.
You can't do calculations with them? Okay. Yeah, it doesn't make sense to like average people's zip codes and get something meaningful. Maybe they should have assigned them in that way though. Like the average of 2 zip codes gives you another zip code that's like halfway in between or something meaningful like that. Right? You know?
How are you gonna do
That might actually be somewhat meaningful. You know, maybe we can do some calculations. But yeah, adding 2 zip codes doesn't necessarily give you another zip code. You know, I don't know. Maybe, I don't know. We have some issues with that. Okay. Yeah, did someone else say that one? Yeah, that's a good example too, right? It's not actually, yeah, how did someone, you were saying, someone up here was saying a good way to say it. It's not something that you can measure, right? And that's the definition that's up here too. Okay, so that's good. Refer to the definition. It's actually still somewhat of a nebulous, definition still a little bit. This can be actually, even though it seems somewhat cut and dry, we've just kind of phrased it in a way that sounds cut and dry. It actually can be a little bit of a debate, right? Can you think of a way to make one of these things down below in yellow quantitative? How could we make color quantitative? Could you think of a way to do that? I don't know. Yeah.
You can make it like we can kind of correspondence number with like the frequency of like the light or whatever.
Yeah, you could actually like do something scientific. You could give like an ordered triple RGB value kind of. We could come up with something, right? What about rides at King's Dominion? How would we quantify favorite ride that? Could you come up with a way to make that quantitative? Yeah.
Take a sample. By sample of like this ride, like this many people say this is
All right, but even then, that's still gonna be. Here's, yeah. Go ahead. Give another.
They bring on the maps. They have like
Okay, but then it doesn't make sense to. Yeah, that would still be.
Measure like how fast the rides go.
That doesn't. That would measure how you could do something like that, but that wouldn't necessarily quantify whether people like that or not.
Number of
Yeah, exactly. Number of loops. Yeah, how good a ride is, you can come up with a measure based on physical properties of the ride. Were you going to add something like that, David?
Yeah.
Okay.
Number of people who ride it every day?
Oh, I like that. Number of people who ride it every day. Okay. I think that's bridging on the right idea. You can take a survey and have every ride and everyone ranks it, right? On a numbered scale, right? You might think, oh, favorite book. That's qualitative, isn't it? But what if we said, like, we could make it quantitative, couldn't we? Let's go look up the Amazon 5-star rating. Oh, this one gets a 4.42. Right, so maybe we can make it quantitative. This is up for debate, isn't it? All of this. You could make things that seem nebulous and categorical. If you're constructing a really great study, you could probably make it quantitative, right? At the end of each semester, I give a student survey, right? And I try to quantify things that are nebulous, right? That's what we do. All right, and then if you have, of course, we're interested in numbers. We'd love to work with quantitative things. That's, of course, the thing we can work with. So then inside this idea of quantitative data, right, we have these 2 distinctions that we add on top of the mix. Discrete versus continuous. Okay. And I think, again, intuitively, you maybe think like, oh, this is pretty cut and dry, but we could have a debate about some of these too, right? So the first stuff is, again, this is counted versus measured this time, okay? Now that's a little unfortunate. The previous definition we used was talked about measured, but so does this make sense? The examples are good, okay? So we're talking about the number of students in your English class. That's a discrete value. It's something you can count. The time it takes a student to travel from home to school, down below. That's obviously, could that take pi minutes? Actually, yes, right? Like that could take on the value pi minutes, right? Huh? The infinite number? I mean, pi is a finite number, but we're guaranteeing values on a continuous spectrum, right? I mean, it's still maybe a little bit not very technical way to say it, but So, like, talk about some of these, and feel free to offer a debate. Now, we're going back to both slides here on this, right? I'd like you to answer whether it's qualitative or quantitative first, and if it is quantitative, then we'll also say whether it's discrete or continuous. So let's just knock them out. What about that first one? Yeah, qualitative, I mean, again, one could make it quantitative, right, by a modification of that, rate it on a scale from, right, but no, the way it's phrased, I think we're gonna have to say qualitative. What about number 2? Quantitative, discrete, and that's kind of like the English class one, yeah. Number 3, what about time it takes to finish an 8K race? Who runs 8K? Is 8K a common distance?
Yeah, it's okay.
Okay. I just haven't heard very many people running 8K.
Like a really good time is like
I feel like everyone runs 5K and 10K. Maybe if you're working up to a 10K, you run an 8K. Okay. What was the answer though? Quantitative, continuous, right? Because I mean, we're thinking time as being indivisible. Yeah. What about height? Of a quantitative, continuous also?
Is it tight or is it like they can't stand?
Yeah, exactly. Yeah, I know. I thought a lot about this because I have 2 little babies at home, right? So my daughter has a height and my other daughter has a length right now. Exactly. You're right. You're right. Until she can walk, I think it's a length. Yeah. Yeah. Which is different for every. So you didn't have a height until you could walk. So for my daughter, she didn't walk until really my oldest daughter until she was really old. So like a year and a half old or something. It was really old. Like that's way old. You don't know it because you don't have babies around. But that's like really old for a baby, right? So she didn't have a height until she was like a year and a half old. Most kids walk like around a little before around a year old. So that's when you probably got a height bestowed upon you. But still. And again, you want to it's too late for you, but you know, as a kid, we should celebrate when like you're 5 feet tall or something like that, right?
We'd be able to legally change our height.
But you have to answer like every day.
I know. You have to approximate, obviously.
Sure,
Obviously. Right? Where are we at? Gender of a student. What do you, qualitative, all right? Number of errors on your last math quiz. What do you think there? Is everyone hearing the answers that are being shouted out? Quantitative, discrete, yeah. Yeah, no, we're not going to say. We're just going to say it's discrete, yeah. Remember, I should also say, discrete doesn't necessarily mean finite, right? I think there's maybe a confusion about that, right? Discrete could be, I mean, you could have 1,000 errors, right? There's no problem with that, right? Okay. Really, each one of these could be rephrased in the following sense. What is the domain, right? I mean, if we're talking about math sense, or in probability theory, right, we think about the support of the distribution, right? What are the possible values that can be taken in the sample space, right? So here, you know, the domain for time it takes to finish an 8K race, what is that going to be? Maybe we're going to say the domain is or the support of this distribution would be. I think we can't say 0, right? But we can say maybe the open interval 0 to infinity or something. But maybe you could run it if you were like, I don't know, an electron or something. You could run it in well, I think that it would be like 0.0 something, right? It can't be, that's why I use an open, just for you. I use an open interval, right? Because it could be very small, but it can't be 0, right? So, is that good? What the domain? Same with the height of a newborn child. That would also be, 0 to infinity. Even though obviously there's a more reasonable domain that we could assign to it, probably, right? My children are very tall, though, so whatever. I don't know. There's an upper. The domain here, though, for a gender of a student is this discrete set, right? M, F. We can actually, do you see what I'm saying? Number of errors. The domain would be 0, 1, 2, right? It's an infinite set, but it's discrete. You understand the difference? Okay. All right. That's like a kind of a technical way to say it. Number of stuffed animals in your room? Discrete. Yeah, it's quantitative, discrete. What about weight of stuffed animals in your room? Yeah, it's quantitative, but it's continuous. So I hope you're appreciating that. Okay. Any other questions, comments about that? I like to, let me make one more distinction because I think that there's something interesting happening here. Let's talk about 7 and 8 for a second. For discrete data, we have, we talked about discrete data exclusively in the last unit, didn't we? We talked about only discrete probability distributions, right? We never did ones like this. Maybe you didn't notice, right? But I never asked you, because of the nature of this course too, I never asked you for the probability that your phone call will be between 5 and 7 minutes. We didn't do that, right? We just didn't do those kinds of probability questions. They were always like, what's the probability that the number of 5s you roll is 7 or something when you roll 12 dice at once or something. It was always like a discrete distribution. And in fact, the word I used was a probability mass function, right? And you could visualize that using like points or something like that, or you could visualize it using like a histogram of some kind. And every bar on this histogram gives the probability of that discrete thing happening, right? Versus continuous distributions, like the weight of your stuffed animals, right, have probability anyone want to guess the word here? They have probability density functions. All right, so that's what that would be the terminology, and then you have some kind of cool curve like that. You appreciate the difference? So, huh? You okay? All right. So and in fact, actually, discrete things. So here's a debate that you can start having too, because we can talk about how we actually like measure something. Like, how about the cost of something? Is that discrete or continuous? I don't know. What do you think? I mean, I think the cost, you might argue the cost is a continuous thing, right? But we also have this issue of reporting. Like technically, is your height discrete or continuous? Well, it's continuous. I think we can agree that it's continuous. But like how people are going to report it, no one will ever round to like the 50th decimal place when they're reporting your height, right? Like our tools are just not that good. So actually, your heights probably, there are probably only like 1,000 heights that anyone ever reports in the history of the world, right? Like, does that make sense? Like, because we only report to like inches, maybe half inches or something. No one or quarter inches if you're like sensitive about your height. Whatever. Okay, but the point is, you might make continuous data discrete, right? By choosing intentionally to report it to a certain degree of accuracy or something like that. That's completely fine and legitimate way to discuss data. But in the limit, you have this nice continuous distribution. I hope you appreciate that as we make data less discrete, as we make it more and more, as we make those bins, those classes really, 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 really infinitely small even, you get in the limit this nice continuous distribution. Okay? And I can't say too much more without actually like teaching you calculus, right? Because the area under this curve is 1, right? Makes sense because we can add them up. And with calculus, we can say the same thing over here. The area under this curve needs to be 1, but that's a hard thing for pre-calculus students to swallow at this point in your life, right? How do we calculate the area under a curve is a question for calculus students. So just stay tuned, that's what pre-calculus is all about. It's all about like making you excited about calculus. Okay, so there you go. So the question, we can at least appreciate this, right? We can ask like, what's the probability that you have 3 stuffed animals, right? Oh, I know. It's, whatever, 2/15 or something, right? Whatever this distribution says it is, Yay. What is the probability that you have, that your mass, the total weight of your stuffed animals is 3.7 pounds?
You can use like a normal CDF.
What do you think? What is the probability? It's not necessarily normal, sorry. It's actually really not normal, okay? Because stuffed animals are not normally distributed weight-wise, okay? It's really weird. It's really strange, yeah. All right, but how would you compute that it's, how would you compute that? You know, here's 3.7, say. There it is on the distribution, I don't know, pounds. What's the probability that your stuffed animal will weigh exactly 3.7 pounds? What do you think the answer is?
Zero.
It's actually 0, yeah. Right? Because you're asking for the now how could that be? I claim mine are, well, okay. I'm talking about, when I say the probability that x equals 3.7, I'm making a really, really bold claim. I'm saying, what is the probability that x equals 3.7, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? And so, can you really claim that you're, I mean, you weighed it with a really precise scale, but can you really claim even with that precise scale, that's what you got? It is still, actually, well, all right, now I'm gonna stop talking about that, okay? Because this could get really deep, right? So the questions when we will do an example of a continuous distribution soon, very soon. The normal distribution we will do, I promise. Yeah, we'll say something about that. Those in stat are like, you know, dying to say something about that. And when we ask questions about this, we're not going to ask this question ever. Or if we do, the answer is 0, okay? But we're always going to ask between values, right? What is more reasonable would be to ask, hey, what's the probability that your stuffed animal weighs between 3.65 and 3.75 pounds, right? You have like a tolerance on it. And then now we have like, now we have the area of like, of a little strip there. And we can actually, that's actually something that's not 0. Yeah, okay. I've said way too much, okay. Once we visualize distributions in this way, we can think about them as being symmetric, right skewed, or left skewed. If this terminology is new to you, don't worry, it's not hard. A symmetric distribution, now, unfortunately this one looks kind of normal, right? The symmetric distribution could look like this too, right? This is a nice symmetric distribution, right? Where the mean and median correspond on any symmetric distribution, including the nice normal looking one that we have here, this nice bell curve. If the distribution, if some of the data gets pulled over to one side here, so here it looks like we've kind of dragged this to the right a little bit, right? We've taken a tail of this distribution over here, and we've pulled it to the right a little bit. That would be called right. It's like you take the Play-Doh and you like grab it and pull it to the right. Can you imagine doing that? Then what does that do? Well, it doesn't, it may affect the median depending on how much but the mean is the thing that's going to be most affected by that. In fact, if like take a look at this little discrete probability distribution for a second here, okay? Say we have this distribution of data. Yay, mean and median both lie right there at that tick mark, say. And then instead we take this guy off and we move it over here, right? Now here's the new distribution. What happened? Well, the median is still exactly where it was before, but the mean gets dragged over to here or something, right? Somewhere, now that maybe the mean, that's maybe an exaggeration, but the point is the mean gets drawn over, doesn't it? Now, is that good or bad? Well, let's not make a judgment call on that. Sometimes we want that to happen. It's not necessarily bad that that's happening. Sometimes we don't want that to happen. You know, sometimes we think that no longer characterizes the data in a helpful way or whatever. Sometimes it does though. So you understand how the mean and median interact. I hope that is fairly clear. So this is like the classic example. I'm sure someone's showed you this before, right? Or so you've thought about this before, maybe, right? I hope. You know, and this is why. You know, well, let's take a second to digest it first. Do you see what each person is saying? Okay. Now, like, so if someone were to pretend you're not looking at this chart, and someone were like, yeah, you know what, you know, if you come to the expected value of our salaries at our company is $70,000. You know, someone said that to you, they would be correct, right? Because technically the expected value in the proper like capital E, capital V mathematical sense is $70,000. Like that is in fact the mean, right? But does that like fairly characterize like how much you're gonna make if you come? Probably not, right? So that's the point here. Yeah. Does that make sense? What's that? Yeah, you just have to come and be president, exactly. That is why almost universally, income, home prices are all reported using the median, right? You've never heard of the average home price. You always hear the median home price in Montgomery County is whatever, because it doesn't make sense to like talk about it because there are like a couple people who live in like this fancy neighborhood. Okay. most people, we want to characterize it correctly, right? All right, we should say something about population in the sample. This is all we're going to say about it, though. I think we kind of, maybe you've hinted at this before, maybe someone has talked to you about it before. It is exactly what you think it is, right? Like if we're taking a survey of the school, we want to know something about the television ownership of the school population. That's the example that we gave you in the homework, the notes packet from Monday, right? I had 600 people on that survey, right? That's not the whole school. Maybe that's a sample of the school. It's maybe infeasible to ask everyone in the school. It's actually not that infeasible to ask everyone in the school. We could actually ask everyone in the school if we wanted. We only have 2,200 students here or something. We could go all the way and ask them all, right? But a good sample, if it's selected in a good way, is maybe as good as actually asking everyone. Maybe we don't have to waste our time. That discussion about how big a sample is needs to be, and how you select the sample is all a question that we're going to avoid and refer you to stat class if you care about, right? I just want to mention it here and now, and then say that IB doesn't really care about that very, very much. IB, if you're taking standard level tests, right? So for more information, go take AP Stat. Higher level math, you'll also be exposed to some more talking about population examples, but for our purposes, we're not going to really say anything more about it than what we just said right now. Any other thoughts, questions? Yeah, Andrew. How do we find the world's population? That's an excellent question. I don't know. By the way, I have a great trivia for you. Where's my trivia fact? Okay, so this is I don't know the answer to that. Sorry. Go look it up. I don't know. How do I find it? I look it up on Wikipedia. How do they find it? I don't know. That's a good question. I mean, obviously, we have reasonable ways of doing that in the United States. But what about other countries? I mean, they don't have a regular every 10-year census maybe in other countries. I don't know. Yeah, birth rate. Yeah, they report, but even though how are they reporting that? I mean, I don't know. How do they guarantee the integrity of those statistics? I don't know. That's a good question, especially in third world nations. No idea. Obviously, there's got to be some margin, a large margin of error on that. Yeah. Plus or minus, what did you say, 6 billion? I think it's not quite that big. All right, so here's an interesting. On that vein, actually, this is the reason you inspired me to remember that I have this. Okay, so this is a Marilyn Bossamont column. Have you asked Marilyn? From years ago, September 23rd, 2007. All right. With my birthday approaching, someone writes, Marilyn Bossamont, who's this genius, right? She's a genius. Highest IQ ever reported. Whatever that means, take it with a grain of salt. Okay, but she is smart and she's cool. With my birthday approaching, I wondered, at what age does a person go from being from being younger than most people to being older than most people in the world? Okay, so do you understand her question? What is she actually asking for? She is asking for the median age of the world, right? So my question is, and actually I think this is a great question, because if you were to say am I old or young? And everyone says well, it's relative. Okay, well actually we can qualify that though. I am old right now because I'm in this room with you guys, right? But when I go hang out with my parents, I'm young, right? It's all relative. So what if I want to hang out with the whole world, okay?
But the average age of the world, the median age is always changing, right?
The median age is always changing. So what do you think the median age was? I have it written down from last year. What do you think the median age of the world was?
16.
Oh, your guesses are all over the place. I love it. I heard a 16 and a 45. What do you think? 30. Okay. It is, are you ready? It's 27.6 in 2014. And that means half of the people in the world are under 27.6 and half of the world is over 27.6 years old. Interesting. Now, let's be real though. What about just the United States? I had that written down too. 36.9. Yeah, all right. Is the median age of the United States? Yes. What country in the world do you think has the highest median age? Japan. Good guess. I mean, you're looking on the one. Yeah, Switzerland. You're making good guesses, right? It's Monaco. Okay. Doesn't surprise surprise you at all, right? Like, we're looking for like rich
Wait, are we-
countries that have a very long life
What
expectancy.
about
Which
the smallest?
state has the oldest population?
Really? What? Oh, Florida, yeah.
What about the like?
All right, now slightly more depressing. Slightly more depressing. What do you think has the lowest median age?
Ghana?
It's going to be somewhere
South
like
Sudan.
it's Uganda, actually. So median age is 15 in Uganda. Oh, it's over actually. Can you imagine that?
Is it about like a lot of people like births or do they have a lot of
Both. I think it's a combination of both. I think people have lots of kids and people don't last long. Okay. Monaco, by the way, I didn't say it. The average, the median age, excuse me, Monaco is 48.9 years old. So, yeah. There you go. So in the United States, I will tell you this, even if you don't know Mr. Chase's age, I am still young with respect to the United States. I'm old, though, with respect to the world. There you go. Interesting, though, right? You can quantify even oldness. You can go home and tell your parents, actually, you know what? I learned in stat class today that you are, like, from a technical definition, old. You know? In the most technical sense possible, you're old. You know, you can actually quantify this. You know. Okay. All right. I don't have anything else to say.